Okay, continuing on with quadratic equations. Again, a quadratic equation is a second order equation whose standard form is going to be ax squared plus bx plus c is equal to 0. And again, we looked at techniques of solving quadratic equations, including the zero product property, as well as the square root property of equality. And also, we have what is referred to as the quadratic formula. And we're still looking at the same coefficients, a, b, and c, and solving for x. This is the formula that we have here. Now, again, so a represents the coefficient of the second order term, b represents the coefficient of the first order x term, and c is the constant that follows. Now, let's say that if we have, in terms of solving by using the quadratic formula, and we'll just say we have an equation such as x squared plus 7x plus 2 is equal to 0. Now, if you notice, we have a trinomial that cannot be factored. And if I try to set up what I have to represent a, b, and c, right? And again, just with x squared, you would have the coefficient at 1, and setting up what we have for a, b, and c. Okay, so a is at 1, b is at 7, and since 2 is added, c is equal to positive 2. And we have, for the use of the quadratic formula, and I'll go ahead and copy this. Okay. All right, so if I substitute, okay, so we have for negative b, so we have negative 7 plus or minus, and we have the square root. B squared, again, is going to be at 7 squared. And we got minus 4ac, so we have minus 4 times 1 times 2. And for what we have in the denominator, okay, so we have a 2 times a, so we have a is at 1, so we have 2 times 1, and we have in following through, okay, so we have for x, again, so we have negative 7 plus or minus, okay, the square root, and 7 squared is 49, negative 4 times 1 times 2 is going to be minus 8, and the denominator, again, we have it 2. And we have for the result here, we can have in compact form at negative 7 plus or minus, okay, the square root of 41 all over 2. And if we look at using this in expanded notation, we can say that we have negative 7 minus the square root of 41 over 2 at the lower end, and we have at the upper end we have negative 7 plus the square root of 41 also all over 2. And so those would be your roots in the case of what we have in solving for x. And both of these are irrational roots. Now let's say that if I change the equation ever so slightly, and let's say that if I put this in the context of where I have x squared minus 7x minus 2 is equal to 0. Okay, so we have here, okay, so little history repeating itself. Okay, so we have a at 1, since this is reference to 1x squared, and since we have 7x and 2 both being subtracted, b is going to be at negative 7, and c is going to end up at negative 2. And if I put in the quadratic equation, so in taking what we have here And once again, substituting. Okay, so we have with negative b, so we have the negative of negative 7, and we have plus or minus, okay, the square root, and we have with b squared, okay, so we have the square of negative 7, we got minus 4ac, so you have minus 4 times 1 times negative 2, and again we have all over 2a, okay, so we have, oops, so we got all over 2 times 1. Okay, so we have in the numerator, okay, so we have opposite sign of negative 7, that will be positive 7. And we got plus or minus the square root. Now, the square of a negative is going to be a positive, and just like 7 squared, the square of negative 7 results as 49. Now, for negative 4 times 1 times negative 2, okay, that's going to translate to a positive 8, and we have all over 2. And so we have in compact form, we're going to have 7 plus or minus the square root of 57 all over 2. And again, if I displayed this in compact notation, we're going to have at the lower end, we're going to have 7 minus the square root of 57 all over 2. Now, at the upper end, we have 7 plus the square root of 57, and we have all over 2. And so for, okay, just another case here with the quadratic formula. Okay, say we have as a third case, and we'll say that we have the equation not yet established in standard form. And we'll say that we have 2x squared plus 5 is equal to 9x. Okay, and if we look at isolating, or I should say moving the 9x over and expressing the equation in standard form, that is setting the equation to 0. Okay. So in the rewrite, so I can readily identify what will represent A, B, and C. Okay, so I have the trinomial in descending degree order. In this case, I have 2x squared minus 9x plus 5 is equal to 0. And from what we have here, okay, this time around A is equal to 2, B is equal to negative 9, and we have that C is equal to 5. And again, just utilizing again what I have with the quadratic formula. Okay, so we have the tools at hand. Okay, so we have for negative b, okay, so looking at the negative of minus 9, and I have plus or minus, okay, the square root. And we got with b squared, okay, so I had the square of negative 9, and minus 4 times 2 times 5. You have all over 2a, so you have 2 times 2. As you get nearer to the set of solutions, okay, so we have at the front, so you have negatives cancel out, so you have 9 plus or minus the square root. Square of negative 9 is 81. Negative 4 times 2 is negative 8 times 5 is negative 40. We have 2 times 2 is 4. And so we have 9 plus or minus, okay, the square root, 41 over 4. And this is, once again, the compact notation for this solution set. But again, if you had to write it in expanded form, once again, as Alex may require it, okay, so we would have at the upper end, we have 9 plus the square root of 41 all over 4. And at the lower end, we have 9 minus, okay, the square root of 41 also over 4.